Calculus 6, 8, you have the notes paper. Basically this whole front just has information that's somewhere in your trig memories that needs to be refreshed and a little bit re-practiced, because on the next lesson when we do calculus with trig, these things come back. But there's not one calculus thing in this whole lesson. This is all just sort of trig, reminder, refreshing, so maybe that's good news. But the front talks about some different things about inverse trig functions. You might remember inverses get you angles. Anytime on your calculator you've ever hit the yellow button for the second key to do trig, you're doing an inverse to get you an angle. So the top line here has a description that for inverse sine of x, that the domain, the D stands for domain, goes from -1 to 1. That just means that sine itself can't go higher than 1, can't go lower than -1. If you tried to do an inverse to go backward and use your calculator, those are the highest and lowest numbers you could input. If you would try your calculator right now to do like inverse sine of 2, it would give you an error. That's out of bounds. If you do sine of anything, sine of this, sine of that, sine of this, sine of that, you could push sine of anything you want all day long. Every answer would stay between -1 and 1. And then when you reverse those, you could get your angles back using inverse sine. The range thing doesn't really greatly impact your life. If I were in person, I might try to explain that more in some detail to you. But bottom line on the range is, the note on the way left margin, if the problem ever throws you a negative for sine, you're going to just make the answer negative. And I could explain that in person probably better, but for your purpose of getting through the homework and refreshing things, that should get you through today. For cosine, if the answer in a cosine problem, if they throw you a negative, you're going to do pi minus something. In trig, we sometimes did 180 minus things too, because we had degrees were an option, but the calculus book is all radian all the time. Tangent, the trick for tangent is if they throw you a negative, you want to throw them back a negative. This middle section is just reminding you that secant and cosine are flipped versions of each other. Cosecant and sine do that. Cotan and tan do that. Then there's a reminder section about Oscar and his heap of apples, sine and cosine and tangent, and who is who. And then there's a reminder chart. The chart, a couple of them are written a little differently. In trig, we memorized √2/2 was a number we did. This section of the calculus book, they prefer 1/√2. So if you see 1/√2, that's the way I wrote it on this paper. In your past, we always have fixed roots on the bottom in trig. That's what our trig book preferred. So 1/√2 today is √2/2 from before. Likewise, 1/√3 is how I wrote it on this, because it's how the homework is going to work. In your memories, that's been √3/3 usually. But this whole front is just reminding you of there is a chart that exists, the what's positive where thing is still around, who is the flipped version of who is around, Oscar and his heap of apples is around. And the main thing off this top group of notes is if they sneak in negatives, these notes on the left are going to be impactful. Sine, they sneak in a negative, just make it negative. Tan, likewise. But cosine, you'll have to do pi minus things. So that's just reference. The back is where the stuff is. So on the back of the notes, I have the problems that are on the board. Basically, they're just expecting you to run the chart backwards. So if you go to look for cosine, and you go to look for this 1/√2 thing, it's on the front face of that chart, cosine, 1/√2, it would lead you to pi/4. However, if that negative weren't there, we'd be done. We'd say pi/4 and get out. But since the negative is there, the key thing from that top group of notes is to do pi minus what the chart says. This is like it's over invisibly at 1. Common denominator of 4 might be nice. If we do a 4 on the bottom, we do a 4 on the top. That invisibly has a 1. 3 pi/4 is what we're shooting for there. This one's easier because I didn't sneak a negative in. I just did a basic fraction. 1 over root 2 is on this chart. For sine, we grab it. It is again coming back pi over 4. If I had slipped a negative on there, you would just slip a negative on the answer. Not as hard of a transition as cosine sneaks a negative. We had to do a pi minus subtraction. Inverse tan of 1, we look for 1 in the tan column. We find it, we trace it back to the beginning, and it shows up pi over 4. Secant's not on your chart, but secant is friends with cosine. To translate a secant into a cosine, this is right now on a 1, we'd have to flip that. So if I look for cosine, and I look for this, I find it, and for the 4th problem in a row, I went heavy this day. I was in a pi over 4 kind of mood, apparently, because I just went crazy with that. Cosecant's not on your chart, but it's friends with sine if we flip. This is over 1, so we flip it. We look for sine, we look for half, we can find sine half column matches up with pi over 6. But when I sneak the negative in, you have to match me by sneaking a negative in. The last one of those, I threw you cotan, so you need to exchange for tan. By again flipping, that's over a 1, so we flip it. 1 over root 3 in the tan column lines up with pi over 6. But I sneaked in a negative, so you sneak in a negative, and then we're good. On the homework, that bunch of stuff corresponds to numbers 1 to 12. 1 to 12 is just doing that over and over and over and over. Then there's a section in the homework page, which is 407, starting with 13 and going to 16. They're going to give you information to make a drawing. They're going to tell you that sine of 2/3 could lead you to an angle. So you need to draw a right triangle, pick an angle. I'll pick this corner because I feel like it. From this angle's point of view, that's the opposite, that's the adjacent, and the hypotenuse is always the longest one. Sine is the Oscar had part of Oscar had a heap of apples. So 2 is the opposite. 3 is the hypotenuse. We can figure out the adjacent by using the Pythagorean theorem. Square the numbers, subtract them to get a leg, and then root. If it were the hypotenuse we needed, we would have added. But if we square this is 9, square this is 4, subtract is 5, this would be the root of 5. What they're asking for is to find all 6 answers. So when we look at this picture, sine is Oscar had, 2/3. Cosine is the heap, root 5 over 3. Tan is the of apples, so 2 over root 5. And on today's homework, the book doesn't care about roots on the bottom, so just leave it. But on a quiz test, my preference is to root 5 over 5. So what you want to do for today, that's up to you. But 2 root 5 over 5 would be ultimately what I'm after. Sine can produce cosecant if we flip. Cosine can produce secant if we flip. The book will be today fine with this. Long term, I'd rather have 3 root 5 over 5. Cotan would be root 5 over 2. And that's one of the benefits of not fixing this. Because if we fixed it, and then we flipped it, we'd still have a mess remade to refix. If you just leave it, it makes it easier to flip them. That'll take you for a little bit. Then the homework at 17 to 28's part of the world is basically supercharts. It's like a supersized version of what we did over there. We're just working the chart back and forth. So if I want to do secant from the chart, I would have to think cosine is its friend. I'd have to flip that upside down. And if I check the chart for cosine and root 3 over 2, that would locate me a pi over 6. However, I sneak the negative in on a cosine problem, so the payment would be to go pi minus this. That's going to end up 5 pi over 6 in the long run. If we try to do pi minus pi over 6, this is over 1, which needs to be a 6, which needs to be a 6, which is friends with a 1. That's how I pulled the 5 pi over 6. I'm not messing with cotan yet, and the parentheses that wrapped up a lot of stuff are still there. Cosecant is friends with sine. We'd have to flip that. Sine and a half is pi over 6. But I sneak the negative in, so you sneak a negative in. To tidy this up, I would need to add these, which would be invisibly accounting for the 1 of 4 pi over 6, which is a 2 pi over 3. Some radius supergeniuses will just live, or radian supergeniuses will just live with the radians. I don't think you guys ever fully embraced radians. So if you want to then figure out cotan of that, your best thing is to think about this. In degree form, pi is the same as 180. 180 dividing 3 is 60. 60 times 2 is 120. 120 lives in sine's quadrant. Since it lives in sine's quadrant, it's a negative answer. Cosine would only be positive in its own quadrant and the all quadrant. We're in sine's quadrant, so we're negative. We always retract to the x-axis. 120 away from 180 is 60. Cotan is related to tan. So if we look up the tan of 60, the chart says root 3. Cotan won't be root 3, it's flipped. This is over 1 right now, so 1 over root 3 in the final analysis. That's as big or bigger than anything in that section. Some of the problems in that section are smaller, there's nothing bigger than that. So that's a pretty representative example of the worst it could go. The last part of the homework and the last part on the board is just using a picture to basically play Oscar Has a Heap of Apple games. What this is asking you to do is draw a picture with tan being this. So back to that kind of an idea. Here's my angle, O's, A's, H's. Tan is Oscar had a heap of apples. So an X goes in the O position. A 3 goes in the A. Well, I did that backward. Nah, that's the H. That's the A. The 3 goes in the A position. The hypotenuse, you'd have to square these, add these, and then do a root. 3 squared is 9. X squared is x squared. Adding them, they're not like terms, so we're just stuck with that for a picture. Okay, so the tan that they gave us led us to put x and 3 in the right slots and finish our triangle with the Pythagorean theorem. What they're after is us to now do the secant. It would be the equivalent of only having to come up with that one answer. We just did this a minute ago with numbers to get 6 answers. They just want us to get the one answer for secant only right now. So secant relies on cosine, which is the a heap part of it. So 3 over this crazy root would be cosine. Secant then is the upside down version of that with the crazy root on top of 3. So we're just trying to absorb and remind all that old trig stuff, charts, Oscar and his heap of apples, that whole bit. There's a 407, it's odds to 39, and like we are in person, any day that it's like just bad, we could always do the evens, and I could make a PDF of the answer book and send it to you by email to check your evens if you want to elect to do the evens. Most years we only do the odds here and move on, but this isn't most years, so we'll just go whatever pace you guys can do without stressing you out interminably more than you're usually stressed out. Try to keep your stress level at an even keel compared to normal life. So, see ya.